Okay, welcome to MBA 507, the YouTube where we're going to go over the solutions for the assignments for Chapter 10. So we had review questions 1, 2, 3, 4, 5, and number 8. Where did I put my sheets? Just here. Hold on, let me find my. Okay, there it is. Put it in the wrong pile. Okay. Review question 10-1. What is capital budgeting? Why is capital budgeting such an important process? Why are capital budgeting errors so costly? Capital budgeting decisions involve investments requiring large cash outlays at the beginning of the life of a project and commit the firm to a particular course of action over a relatively long time horizon. As such, they are both costly and difficult to reverse because of, one, their large cost, and two, the fact that they involve fixed assets that cannot be liquidated easily. Building a new plant, putting in new machinery in an existing plant, it's a expensive, lengthy commitment. Why? Number 10 review question 10-2. What are the disadvantages of using the payback period as a capital budgeting technique? What are its advantages? Why is it so frequently used? Well, there's two big criticisms with the payback method. For the most important, the biggest, is that it ignores the timing of cash flows that occur during the payback period. All it does is measure how long it takes you to recoup your cash outflow. The second is it ignores all cash flows occurring after the payback period. So it's just interested in how long it takes you to recoup your investment or your initial cash outlay, and it doesn't really tell you how much the outlay, the investment is going to, or project is going to return to you. Now, the advantages, there are 4 of them. It deals with cash flows rather than accounting profits, and therefore focuses on the true timing of the project's benefits and costs. Secondly, it may be a useful decision rule for capital-constrained firms that need relatively quick repayment on capital outlays. Third, it is easy to calculate and understand. And fourthly, it can be used as a rough screening device, eliminating projects with returns that do not material until later years. Review question 10-3. In some countries, the expropriation, seizure of foreign investments is a common practice. If you were considering an investment in one of these countries, would you use the payback method criterion? Would the use of the payback period criterion seem more reasonable than it would otherwise might? Why or why not? So when you have the risk of making an investment in a foreign country, and you're at the risk of having your investment expropriated, that is claimed by the government, and you're out, SLO, you know what that is. And so it increases the risk. Method may be the preferred method. It eliminates the project returns that do not materialize until later years. So you're going to have a quick payback before they can expropriate your investment. So you're emphasizing returns early in the life of a project/investment. A country experiencing frequent expropriations would certainly have a significant amount of uncertainty. And think about it from their standpoint. If they're doing that, what are they telling? They're discouraging foreign investment. So for third world countries that need capital and need financing to get their economies caught up to the rest of the world, they discourage expropriation. So anyway, in cases where there is the risk of expropriation, the payback period criterion could be used as a rough screening device or filter to filter out riskier projects that have longer lives. Review question 10-4. Briefly compare and contrast the net present value, the present pay, what's it doing, and the NPV, net present value, the PI. Hold on, getting summoned. Okay, I'm sorry. Returning to review question 10-4, briefly compare and contrast the NPV, net present value method, the profit index, is it? PI, profitability index, and the internal IRR, internal rate of return criteria. What are the advantages and disadvantages using each of these methods? Okay, the three discounted cash flow capital budgeting criteria are the net present value method, the profitability index, and the internal rate of return. The net present value method gives an absolute dollar value for the project by taking the present value of the benefits, future benefits, and subtracting the present value of the cost. So if you get a positive number, the project or the investment should be undertaken. The profitability index compares the benefits and costs of the projects through division and comes up with the measure of the project's relative value, a benefit-cost ratio. The internal rate of return tells us the rate of return that the project earns over its lifespan. In the capital budgeting area, these methods generally give us the same accept or reject decisions on different projects or investments, but many times rank them differently. As such, they have some general advantages and disadvantages. The advantages associated with these discounted cash flow methods are as follows, and there are three of them. The first one being they deal with cash flows rather than accounting profits. Fundamental concept number one, cash flow is what matters. Secondly, they recognize the time value of money. And thirdly, they are consistent with the firm's goal of shareholder wealth maximization. Now for the disadvantages associated with these discounted cash flow methods. The criteria requires a detailed long-term forecast of cash flows associated with the project, which may be difficult and time-consuming to generate. Plus, their forecasts, you could be wrong. Okay. 2, they also require an estimate of the appropriate discount rate. For new or risky projects, this may be somewhat difficult to determine. Plus, the longer life of the project, you'll probably experience more of a change in interest rates or the discount rate used. The internal rate of return criterion assumes that cash flows generated over the lifespan of the project can be reinvested at that same internal rate of return. This may not necessarily be a good assumption. If you've been watching the financial news or even the general news, there's been a lot of talk the last 2-3 months about inflation. So when inflation goes up, interest rates are going to go up because the dollar has less purchasing power. So if you start a project that is giving you a required 5% rate of return, if inflation is 6%, you're going to be losing out. You want to up that to 7 or 8%, something higher than the rate of inflation. If you go back to chapter 3 or 4, when we're looking at what goes into the interest rates, there's a maturity factor and maturity risk and the inflation risk. Well, the inflation risk has been non-existent for the last 15, 20 years, but now it's starting to rear its ugly head once more. Again, I've been around long enough. I've seen inflation as high as the mid to upper teens, and it was terrible because you get paid every 2 weeks and you get locked into a salary for 1 year, which is a fixed income. And yet prices are going up. Costs, started out putting $20 of gas in your car to get to work. Then it goes up to 25 and then 30 and then 40. And you're making the same thing. Same thing. You go to the grocery store, so a lot of expenses, living expenses, are variable, especially with inflationary times. They're going to go higher and higher, faster than your paycheck is going up. And it's sort of like a catch-22 or a dog or cat chasing its tail. If they do increase your wages, then they're pumping more money into the economy, and more money, again, pushes goods up. The cost of goods up. So it's kind of a vicious circle. Under certain circumstances, a project or investment can have more than one internal rate of return. This occurs when there is more than one sign or reversal in the cash flows. Okay. Again, it could be due to inflation or other factors. 5, without a financial calculator or computer, the calculation of the internal rate of return can become quite tedious, especially for people that are not mathematically gifted. Okay, review question number 10-5. What are mutually exclusive projects? Why might the existence of mutually exclusive projects cause problems in the implementation of the discounted cash flow capital budget criteria? Mutually exclusive projects involve 2 or more projects where the acceptance of one project will necessarily mean the rejection of the other. You can't do 2. You can do one or the other, but not both. This usually occurs when a set of projects perform essentially the same task. Relating this to our discounted cash flow criteria, it means that not all projects with positive net present values, profitability indexes greater than 1, or internal rates of return greater than the required rate of return will be or should be accepted. Moreover, because our discounted cash flow criteria do not always yield the same ranking of projects, one criterion may indicate that mutually exclusive project A should be accepted, whereas another criterion may indicate that the mutually exclusive project B should be accepted. Okay. So again, you might want to look at more than one of those. I think I touched on that on the lecture discussion on Chapter 10. Companies usually do that. Plus, they'll usually, since we're using forecasts and estimates of future cash flows, you can't know them with any certainty. They'll usually do several with a low, medium, high range, 3 at least. The most likely, a little bit less than likely, and a little bit more than likely. So you can say optimistic, pessimistic, or most likely to happen, or average. And finally, review question 10-8. Or when might 2 mutually exclusive projects having unequal lives be incomparable? How would managers deal with this problem? The problem of incomparability of projects with different lives is not a direct result of the projects having different lives, but the fact that the future profitable investment proposals are being affected by this decision made currently. Again, the key is, does the investment decision being made today affect future profitable investment proposals? If so, the projects are not comparable. Although the most theoretically proper approach is to make assumptions as to investment opportunities in the future, in most cases, this method is probably too difficult to be of any value. Again, assumptions about the future. Thin ice, risky ground. Again, this is why economists and actuaries and all these kind of high-priced specialists are called in to work up the numbers. And financial analysts, it always amazes me when quarterly earnings come out, and these financial analysts can pretty get, not to the penny, but within a few cents. They're pretty good. Of course, they're only looking 3 months out. when you're looking at 5 years out or 10 years out, it gets harder and harder more difficult to make estimates about the future the farther out you're looking. Okay. Thus, the most common method used to deal with the problem is the creation of a replacement chain to equalize lifespans. In effect, the reinvestment opportunities in the future are assumed to be similar to those of the current period. Again, whenever you assume, you have to be very, very careful. All right, what do we have here as far as the study problems? Look at my syllabus, number 5. All right. Net present value, profitability index, and internal rate of return calculations. Fujisawa Inc. is considering a major expansion of its product line and has estimated the following free cash flows associated with an expansion. The initial outlay would be $1,950,000, and the project would generate incremental cash flows of $450,000 per year for 6 years. The appropriate required rate of return is 9%. And then they want us to calculate the net present value, profitability index, internal rate of return, and then finally make a decision whether the project should be accepted or not. Okay, so study problem. (10-5). Okay, so to do the net present value, get our trusty handy calculator, statistical calculator out, and you want to do the sum of, for 6 periods with the data they give you. So 6, t equals 1, and then we put the numbers in. 450,000 per year for 6 years. 1 plus the required rate of return of 9%, minus the initial cash outlay of $1,950,000. So that breaks down to $450,000 times 4.4855 minus the $1,950,000. So that would give us $2,018,663. Those are the cash inflows from the project. Subtract out the cost or the cash outflow of the project of the $1,950,000. And we see the net present value of the project would be $68,663. So based on net present value, you would accept the project. You would go with it. Now the profitability index. All that is the cash inflows from the project of $2,018,663 divided by the cash outflows of $1,950,000. Give us 1.0352. So it's greater than 1. So again, we would accept the project, go ahead with the project. Now the internal rate of return. We're just going to use our financial calculator and put in just let me get these down, everything down here, give you a peek at it. Okay, so we have N for the length of the project, which is 6 years. The compute interest per year is the required or the internal rate of return that we're looking for. That's why I have that arrow for it. And we know the present value is an outflow of $1,950,000, and the payment per year is the inflows are $450, and there is no future value. So now I'll put the numbers in. 6 for 6 years. I'll put a question mark for the rate because that's what we're looking for. The present value is a cash outflow of $1,950,000, so I'm going to put it in as a negative $1,950,000. The per annum inflows are $450,000. And the future value is 0. So once you get those in your financial calculator, all you have to do is hit compute I/Y or compute interest per year, and we will get 10.17%. Let me see if this highlighter's any good. Now let's go with the pink. It might stand out a little bit better. So it's obvious all three methods give us a, the required rate of return is 9%, and we're getting a 10, so we're greater than that. So part D, we would answer in the affirmative, yes. The project should be accepted. Okay. D is our conclusion. Yes, make the investment, make the outlay. Spend the $1,950,000 because we're going to get $2,018,663 over 6 years. And those numbers are reduced to present values, so we can compare apples and apples. Okay. Number 6. Study problem. (10-6). Payback period, net present value, profitability index, and internal rate of return calculations. You are considering a project with an initial cash outlay of $80,000, expected free cash flows of $20,000 at the end of each year for 6 years. Boy, they like 6 years. The required rate of return for the project is 10%. So they want us to calculate the payback period, the project's net present value, the profitability index, and the internal rate of return. Okay, so part A, payback period. Okay, so the initial outlay is $80,000. and it's going to bring in $20,000 per year for 6 years. So we have the outflow of $80,000 to finance the project. Project is going to give us $20,000 a year for 6 years. Well, we don't care for that it's going to be 6 years, and it tells us, you do the math there, and it comes out to 4 years. This is the payback period. Okay, so that's what the payback period says. We're going to recoup our $80,000 cash outflow in 4 years. Well, if you got a little bit of logic applied, and you say this is going to bring us $20,000 a year for 6 years, well, years 5 and years 6 are a gross amount of $20,000 each year, a total of $40,000. Yeah, I'd like to see that in present value. But again, it's going to be a positive number, so you would accept the project. Part B is calculate the net present value. We'll use the formula, the sum of the annual cash flows for 20 years for 6 years at the rate of 10%. Minus the initial cash outlay. Okay, so you want to get the present value of $20,000 for 6 years. You can use the Excel spreadsheet, you can use the table factors, or you can do it mathematically or a financial calculator. So the factor for 6 years at 10% would be 4.3553. And right away, I know it's going to be a positive number because 4 would give me 80,000, and it's a little bit over 4, the factor, right here, 4.3553, which makes, multiplied by the 20,000, comes out to 87,105. So that's a present value of the cash inflows, $20,000 a year over 6 years. Think about it. $20,000 a year for 6 years, 6 times 20 is 120. That's gross. This, we're using the present value. What is that today? Well, in terms of today, at 10%, that 120,000 is worth 87,105 today, minus the 80,000 cash outlay. So it comes out to 7,105 net present value of the project. So it's a positive number. We would accept the project. We would make the investment. C, calculate the profitability index. All we have to do is take the net present value of the 6 year, the 20,000 a year for 6 years, which we've already calculated to be 87,105. Divide that by the $80,000 that it's going to cost us, and that comes out to 1.0888. Barely over 1, but it is over 1, so we would go ahead with it. Okay. But once again, the 87,105 is the present value of the $20,000 that is going to be coming in for the next annually each year for the next 6 years. Again, the total amount of that is 120,000, but the dollars in year 2 are weaker than year 1. Year 3 is weaker than both of those, and so on and so forth down the line. So what we're doing here is we're reducing this into that $120,000, which is 6 payments, 6 annual payments of $20,000. What's it worth today? $87,105. The outflow today at the beginning of the project is $80,000. Divide that into the inflows, discount it to present value, and you get the profitability index. Okay. Part D, they want us to do the internal rate of return. So once again, we'll turn to our financial calculators and just get it set up here. Compute interest per year, present value, the payment, and the future value. And what we're looking for is the compute. Okay, so what I have highlighted in pink is what we're looking for, the internal rate of return. So all we have to do now is take the facts they give us, plug them into the calculator. Number of periods will be 6. The payment, the present value going out is $80,000 invested or financing the project. The payment is $20,000 a year for 6 years. Future value is 0, residual. So you put those in your Excel spreadsheet or your financial calculator and then hit compute interest per year. And that comes out to 12.98%. And that's the internal rate of return. So that's greater than the 10% required rate of return. So all the criteria will tell us that this project is a go. They don't ask for it in this instance, but it's obvious if we've paid attention throughout the chapter that all 3 methods, payback method was quicker, it tells you 4 years, and it's a 6-year project. So you're going to have year 5 and year 6 be the icing on the cake, so to speak. The present value, the profitability present value is $7,105. So it's a positive number that will indicate a accept the project or go ahead with it. And the profitability index is greater than 1, barely, but again, it's over 1, so it meets the criteria. And the last thing we did was calculate the internal rate of return. It came out to 12.98%, and they said the required rate of return is 10, so we're nearly 3% to the good with that project. Okay. Study problem number 7. Net present value, profitability index, internal rate of return calculations. You're considering 2 independent projects, project A and B. The initial cash outlay associated with A is $50,000. Initial cash outlay for B is $70,000. Required rate of return on both projects is 12%. And they give us a table there with the cash flows. Okay, and they're even $12,000 a year for A and an even $13,000 a year for B. And they're both at 6 years. So they want us to do the same thing we've been doing. So let's see. Net present value let me draw a line down the middle of the page. We could run them side by side. This would be A up here and B on the right side. I'm just going to do them side by side. So net present value is going to be for A, 12,000, the sum of for 6 periods, $12,000 at 12%. 1 plus 0.1 minus 50,000 for A. That's going to be 12,000 times 4.1114 minus 50,000. And that's going to be 49,337 for the present value of the $12,000 inflow for 6 years minus the 50. So we come up with a negative, put it down the line so it stands out a little bit better. Negative present value of $663, $663. So what does that tell you? Don't do it. You'll lose money. It's not worth it. It's not if you want a 10% rate of return. So let's look at how B works out here. We got $13,000 a year for 6 years. 1 plus 0.1 G minus 70,000. So the facts are a little bit different here. 13,000 times 4.14. Why is that the same? Because it's 6 years, same length of time, and the required rate of return is 12%. Oops, I put 10 in there. Just go back over here. That should be a 12. 1 plus 0.12. I had 0.1 in there. Thought it was 10%, 12%. All right. So now we do the math. And what do we find out? That we get 53,448 as the present value of the 6 years of $13,000 at 12% minus the 70,000. So then the net present value of B would be negative 16,552. Okay, so that would tell you not to undertake the project. Now, if you had to choose between A and B, if you look at the facts, so I'll say, hey, B brings in $13,000 a year. So it's going to bring in $6,000 a year, or $6,000 total. But again, that's looking at it the wrong way because we're ignoring the time value of money. We need to reduce that into present value. The other one is 6 years at 12,000 would be 72,000. 13 times 6 would be 78,000. And if you look at it, and I'm doing this to illustrate, make the point that if you looked at A strictly on total cash, it'd be 72,000 coming in, and B would be what did I say? 78,000. Okay, if you go 12 times 6 years, 12,000 a year, it'd be 72,000. 13,000 for 6 years is a total of 78,000. And if you'd look at that, say, oh, I lay out 50,000 and I get 72,000 out, but you're apples and oranges because the 50,000 is today's dollars. The 72,000 is this year's, next year's, year 3, year 4, year 5, year 6. And we know that each succeeding year, the dollar is worth less because of the ravages of inflation and other factors. The other project B, you lay out 70,000, it's going to bring you in a gross amount of 78. You say, well, B is better than A because A only generates A is better because 72,000 is greater than 50,000. B is also good because 78,000 coming in is better than 70,000 going out. But the 70,000 and the 50,000 going out is in year at the origination, the initiation of the project. We have to discount each of those 6 years payments of 12,000 and 13,000 back to present value today to do a valid comparison. And when we do that, we find out that for project A, we only end up that $72,000 over the next 6 years at 12,000 a year is only worth 49,337 today, and the $13,000 a year for project B for 6 years is a total of 78, but is only worth 53,448 in terms of today's dollars. Okay, now we're going to do the profitability index. And for A, we would put the 49,337 present value of the cash inflows over the cash outflows. And we would see that it comes out to 0.9867. It's less than 1, so that's an indication to reject it. Do the same thing using the numbers for project B, the present value of the 6 annual payments or inflows of 13,000 a year for 6 years. We calculate it to be 53,448. Put that over the cost of that project of 70,000, the cost of that project, and we get 0.7635. Both those numbers, profitability index, are below 1. Right? 0.9867, pretty close, but still under 1. Project B is 0.76, well under 1. So again, another indication that we would not go ahead with either project A or project B. Finally, we have to do the internal rate of return. And we're going to use the financial calculator approach. So let me get it set up here. And compute interest per year. And the present value, payment, and the future value. So again, there's the shell, and now I just have to stamp the numbers up and then press the CPTIY button. So for project A, we have 6 years. The present value is an outlay of $50,000, so it's a negative $50,000. The inflows payments are $12,000 a year for 6 years. And the future value, we zero that out. You put those in the calculator, then hit the CPTI/Y button, and it will magically tell us that the internal rate of return is 11.53. And it says we need, the required rate of return is 12%. Well, this is only going to give us 11.53. So it's below our required rate of return. So again, we would reject the project. Doing the same thing for project B, we just have to change some of the numbers. The years, again, are 6. But now the outflow is $70,000 at the start of the project, minus $70,000. it's going to bring us $13,000 a year in. Future value, again, is 0. Then we press the compute interest per year, and we'll find the rate is 3.18%. $3.18 is significantly below our required rate of return of 12%. So again, using all three criteria, we would reject the project. They didn't ask for the payback in this one, but let's see. For project A, 12,000 first year, second, third, fourth year would be 48. So we'd need 2,000 more, 1,000 a month. So at the end of February of year 5, so it would be 5 years and 2 months, or 5 and 1/6 year, or 4 and 1/6 year for a payback period. And project B be 13, 26, 52, 65, and I would need another 5,000, so 513. So it would be 5 and 5/13, 5 and 5/12. May, somewhere in May, June of the year 6. So what is the payback tells us how long. It doesn't tell us whether we should accept or reject the project. The other methods, the payback. I was looking at the other one. Yeah. Payback wasn't asked for here. Again, it doesn't tell us whether we should. It gives us criteria to make a decision if we're looking just time-wise, how long would take us to recoup our investment. Again, I'm just doing that on not discounting the numbers of the cash inflows for project A or project B. But you can see the powerful tools we have here. Just keep in mind that those future years' cash inflows are projections or estimates. The rates of return are estimates. And again, the good way to, in practice, companies would do this. Project A, they might look at a 10,000 a year. They might look at it at 15,000 a year inflows. Same thing with project B. Okay. They could also move the required rate of return down to 10, or they could bump it up to 14 or 15%. So you can play with a lot of variables, especially with the financial calculator and computers doing the heavy math for us. You can work out multiple scenarios, and you can see the power of them. All right, so hopefully that added to your understanding and enjoyment and knowledge of Chapter 10. Not too much longer, another week and a half. Okay.